Hey everyone, this is the Math Nexus, and today we are going to continue with exercise 2.3, and hopefully we are going to complete exercise 2.3 today. We have discussed the previous questions in our previous lectures, so I won't be discussing the main concepts. And if you want to know them, please do take in consideration my previous lectures. Okay, so we'll jump directly into question 6, and what it says is to find out the stationary points on the curve y is equals to x minus 8, x minus 3. So the thing is, I've discussed in the previous lecture. However, I'm going to give a recap that we have discussed the form a x minus h plus k, and what this form gives us, it is factorized from a quadratic equations, and it allows us to find the maximum or minimum point x and y value. So the x value is h and the y value is k. And similarly, what we are going to say is to find out the coordinates, we have to make this quadratic equation simplify first by multiplying these two, x minus 8 and x minus 3. And then we have to put this into the form ax minus h plus k so that we can find our desired points. So for that, it's really simple. We go to question number 6, part A, and what they've told us to find the stationary point of y is equals to x minus 8 multiplied by x minus 3. And what we're going to do is use the FOIL method, meaning the first, outer, inner, and last. And how we're going to do this, multiply the first constants of the two brackets. So first, x squared, x multiplied by x is x squared. First, the outer constants, so x and 3 are the outer constants in the both brackets. So minus 3x, inner minus 8x, and last minus 8 multiplied by negative 3. That will become positive 8 3s are 24. Okay, now just simplify this up. Y is equals to x squared minus 3x minus 8 is going to be minus 11x plus 24. And as you guys know, we have the coefficient of x squared. It is already 1, so we don't need to meddle up with this equation right now. So what we're going to basically do is start to factorize directly. So y is equals to, I'm going to ignore the modulus for now, or you just leave it. I'm going to place it here. So x squared minus 11x is going to be written as it is. However, we have to give this the form a squared plus 2ab, or in this case minus 2ab plus b squared, and that is going to give us the form a minus b whole squared. That will allow us to connect with this equation by the x minus h whole squared. So x squared minus 11x, and to bring out the b part, we have to divide by 2. 2. So it's going to be plus 11 upon 2 whole squared, and we can't add 11 upon 2 whole squared from thin air. So we have to subtract it, balance down this equation. 11 upon 2 whole squared, and that's going to be added into 24. Okay, so what is going to be next is y is equals to x. Wait a second, x 11 divided by 2 is going to become 5.5. So x minus 5.5 whole squared minus 11 minus 5.5 squared, and is going to be negative 30.25. and add 24 into it. So we are going to get in the end y is equals to modulus of x minus 5.5 whole squared minus 30.25 plus 24 is going to be negative 6.25. So in the end, this is in a modulus, obviously. So that's the equation we have found out. How do we find the coordinates? Okay, the stationary point is a x minus h whole squared. So in negative h is equals to negative 5.5, and as we can see, I've compared this up. Okay, so x minus h and x minus 5.5. So obviously h is going to be 5.5. So, and what is k? K is positive, k is equal to negative 6.25. Now the thing is that the h is the x value of the stationary point, and the k is the y value of the stationary point. So initially we would have got this answer for the stationary point, and that would have been our minimum point. But the thing is, right now we are discussing a modulus graph, and they have clearly showed a modulus encompassing our equation, our quadratic equation. So whenever there's a modulus, we convert the negative y value, not the x value. X values remain the same. However, the negative y value will change into a positive y value. So that will give us 5.5 and positive 6.25. So this is wrong, this is correct, and that's our answer for part A. However, what they are asking is find the value of k for which x minus 8 and x multiplied by x minus 3 is equal to k. So what they're basically saying, and that find the solutions, or the find the y values for which we are going to get three solutions. Okay, so the thing is, let me just explain it at another page. This is question 7 page. Okay, I'm just going to specifically explain this in this page. So whenever we get our quadratic graph, it's something like this, a parabola. If we take this equation only, x minus 8 x squared minus 11 x plus 24, we would have got this. And by the way, this is just an approximation. This is not an accurate graph, just to clarify the fact. So we would get a shape like this. Okay, now this is, they have told us in the graph that this is a modulus. So the curve part is going to get down here, and we are going to get a shape like this. And whenever we discuss modulus graphs, we are going to take the curves. These two lines before the curves are going to go until their limit is going to end. So right now we haven't got any limit. For example, x is greater than, or x is greater than 2, but it is lesser than 7. We have not been given this limits. Okay, so we can say that these parts of the graph are going on and on and on. We don't know till when. Okay, so the thing is, what and this is a graph something like this. So this is the value when y is equals to 0, and this is the value when y is equals to 0. So when y is equals to 0, we are getting two intersections, meaning we are getting two solutions. We make a line at y is equals to 0, we are going to get 2 points. Okay, however, if we make a line at, for example, y is equals to 1, and this is 1, this is 2, this is 3, and this is 4. Okay, for example, if we make a line on y is equals to 1, straight line, what we are going to get is, we are going to get 4 intersections with this new line. So 1, 2, 3, and 4. And we can say that we are going to get 4 new solutions. And then they've told us that we have to find, then for example, at 2, we go up this at this point, and we are getting an intersection. This was a little bit rough line, but for example, I'm just showing this. And we can say that the maximum point of this specific graph is right now 2. And this is again an approximation. This is not an accurate graph. We're just assuming right now. So at the maximum point, at the maximum y value, we are going to get 3 intersections, 1, 2, and 3. So we are going to say that this is going to have 3 solutions. And again, as was in the previous lecture, if we make a line at any point greater than the maximum or minimum, or lower than the maximum, greater than the maximum point for now, and then we are going to get 2 solutions, 1 and 2, and 4, and also for 4, 1, 2, and it's going to go so on and further. But we've got the basic concept. So when does 3 solutions come? When and does that case is going to come? Is going to come when our line is going to pass through the maximum y value, just right through the edge. So we can say that if this y value, the maximum y value for this graph is 6.25, we can say if we make a line through this value, we are going to get 3 solutions. So we can say for the y value is k is equals to 6.25. It is going to have 3 solutions, and that's it. This is our answer for part B. It's really simple, but we have to know the basic concept for that, and I've explained these concepts in greater detail in my previous lectures. So that's why I'm not going to go in as much detail as that. Okay, so we have got through that point. Let's proceed on to question number 7. Okay, so what question number 7 tells us is, we have question 7a. we have a modulus of equation x squared minus 6 is equals to 10. So again, I've discussed in my previous lectures with you guys that whenever we have a modulus and we have to open this modulus up, for example, we have to make this x squared minus 6 independent of the modulus. We do not want this modulus in our equation. So we are going to get one negative and one positive. So a value. So x squared minus 6 is going to be positive 10, or x squared minus 6 is equals to negative 10, and that's going to be applicable for every kind of equation if you want to become independent of the modulus, because right now you're trapped. You can't do anything with this x squared minus 6 until it is independent of this modulus. It's trapped in it. Okay, so to open that trap we have to give out two values on the other side. So for example, it would have been x squared minus 2 in a modulus is equals to 3x plus 2. So that would have become x squared minus 2 is equals to 3x plus 2, or x squared minus 2 is equals to negative 3x negative 2, and that's how it works. Okay, I hope that clarifies your concept. So the thing is, we're going to get two values for this. Again, just simplify these values. X squared is equals to 10 plus 16, which is going to be 10 plus 6, which is 16, or x squared is equals to negative 10 plus 16, which is going to become negative 4. And we are going to get, in a second, yes, so we are going to get x is equal to under root 16, which is plus minus 4, or x squared x is equal to under root negative 4, which is going to give us a math error. This is because, well, you can't put a negative integer inside, or any negative value inside a quadratic equation. Okay, for question number 7, part B. So these questions are really easy for now. So x squared minus 2 is equals to 2. Again, make this independent. X squared minus 2 is equals to positive 2, or x squared minus 2 is equals to negative 2. Similarly, what we are going to do is x squared is equals to 2 plus 2, which is 4, or x squared is equals to negative 2 plus 2, which is going to be 0. So x is equals to plus minus 2, or x is equals to 0. And that's it. This was a really short one. So x squared again minus 5x in a modulus is going to be equals to 6. Again, what we're going to do is make this independent. X squared minus 5x is equals to positive 6, or x squared minus 5x is equals to negative 6. Okay, so what we are going to do is arrange this equation as we want it. X squared minus 5x minus 6 is equal to 0, or x squared minus 5x plus 6 is equals to 0. So again, this is a quadratic equation, and for now I'm not going to solve the quadratic equations as I was doing previously. I'm just going to use my calculator. So x squared 1 minus 5 and minus 6, that's going to give me positive x is equals to positive 6 and negative 1, or for the other part of the equation, positive 1, negative 5 and positive 6. That's going to give me x equals to 3 and x is equals to 2. So again, we have the two values. What we are going to do is really quickly write those down. X equals to 6, negative 1, 3, or 2. Okay, so the or is being applicable to everything where there is a comma. So let's just jump into part D, and we have x squared plus 2x in a modulus is equals to 24. Again, expand this up. X squared plus 2x is equals to 24, or x squared plus 2x is equals to negative 24. So that's going to give us x squared plus 2x minus 24 is equals to 0, or x squared plus 2x plus 24 is equals to 0. And thing is, again, I'm going to use my calculator. In fact, I'm going to use my calculator for every quadratic equation that's going to come in this lecture. So positive 1, positive 2, and negative 24. So that's going to give us x equals to 4 and negative 6. X equals to 4 and negative 6, or x is equals to, for the second equation, positive 2 and positive 24. Wait a second. It's positive 2 and positive 24. And that's going to give us in the form of iotas. So we are going to place a blank here. So we are only going to get x equals to 4 or x is equals to negative 6. Okay, another reason, by the way, is why we are not using the iota values is because it's not in the syllabus for now, so don't concentrate on it. Whenever you get an iota values, just it's the equal of not applicable for now. It's too advanced for you to understand right now. Okay, part E. For part E, we have x squared minus 5x plus 1 is equals to 3 in a modulus. So what we're going to do is expand this up x squared minus 5x plus 1 minus 3 is equals to 0, or x squared minus 5x plus 1 plus 3 is equals to 0. And if you don't understand, I've expanded this and then switched the side in the same step. So x squared minus 5x plus 1 minus 3 is going to be negative 2 is equals to 0, or x squared minus 5x plus 4 is equals to 0. So what we're going to do is take a calculator, input these values. So 1, negative 5, and negative 2. That's going to give us x is equals to 5.37, something like this. Let me see. X is equals to 5.372. And the second x value we are going to get is x is equals to negative 0.372, or you can say x is equals to, for the other equation we have 1, negative 5 and positive 4, and that's is x equals to 4 and x equals to 1. Another thing I want to tell you is we are getting 4 x values for now, by the way. And another thing is that if there's an equation, or for example, if you have a lot of time right now, you have solved your paper and everything, you think you have some time to spare, I would prefer you use the quadratic equation or factorizing method. This 5.372 and negative 0.372 would obviously be solved using the quadratic equation method, and that answer would come in indices or surds. So the thing is, I prefer you to do the long method, for example, the quadratic equation method or the factorization method. However, for the sake of this lecture, I'm going to use the calculator because it's going to be a really lengthy thing if I solve every quadratic equation in this lecture. So please bear with me. Okay. Let me just erase this for some space. We are done with part E. Let me just erase the whole page here. Wait a second. Please bear with me. Then the part E, we have only 4 parts left, and then our exercise will be completed. So let me scale it down here. Okay. Okay. For part F, what we're going to use is x squared plus 3x minus 1 is equals to 3. Okay, so that's going to essentially give us in a modulus part. And this is also. So x squared plus 3x minus 1 minus 3 is equals to 0, or x squared plus 3x minus 1, minus 1 plus 3 is equals to 0. Next, what we're going to do is take this up and solve this. X squared plus 3x minus 4 is equals to 0, or x squared plus 3x minus 1 plus 3 is positive 2 is equals to 0. Again, I'm going to input this into calculator. However, I prefer you should use the quadratic equation method or the factorization method. So that's going to give us x equals to 1 and x is equals to negative 4, or for the other two sets of values, we are going to get 1, positive 3 and positive 2. That's going to give us x equals to -1 and x equals to -2. So x equals to -1 and x equals to -2. So here we have it. We have four set of values for our uh, modulus graph, okay, or modulus equation, whatever you want to say it. So for part G, what we are going to use is x squared plus 2x minus 4 in a modulus is equals to 5, and x squared plus 2x minus 4 plus 5, or you can say, yeah, plus 5 is equals to 0, or x squared plus 2x minus 4 minus 5 is equals to 0. Simplify this, we're going to get x squared plus 2x minus 4 plus 5 is equals to positive 1 is equals to 0, or x squared plus 2x is equals minus 9 is equals to 0. Okay, for this equation only, I'm going to use my quadratic equation formula. A is equals to 1, B is equals to 2, and in this case, C is equals to 1. In this case, A is equals to 1, B is equals to 2, and C is equals to -9. I need more space for this. So the first one is going to be -2 plus minus under root B squared. This is the quadratic equation formula, by the way. B squared is going to be 2 squared 4 minus 4 multiplied by A multiplied by C divided by 2 multiplied by A. Or for the second part of the equation, minus B plus minus under root B squared minus 4 multiplied by A multiplied by -9 divided by 2 multiplied by A, which is 1. Again, simplify this up. -2 plus minus under root 4 minus 4 is going to be 0 divided by 2, or -2 plus minus under root 4 9 multiplied by -9 multiplied by -4 is going to become positive. Wait a second. Wait a second. I made no. It's correct. Okay. So this is going to be -9 multiplied by -4 is going to be 4 plus 36 divided by 2. Okay, so that's going to give us -2 upon 2, or -2 plus minus under root 36 plus 4 is 40 divided by 2. So these two sets of values we are having, we can either say it's x is equals to -1 because it's a -2 plus minus 0, so it's essentially going to be nothing. Plus 0 and -0 is nothing. So x equals to -1, or x is equals to, if you can simplify this equation if you want, so it's going to be, it's something like -1 plus minus, or in fact you are going to counter the indices or search and search chapter. So it's just a trailer of what this chapter is going to be. So in order to open this indice on both sides, yeah, so what we are going to do is take the LCM of 40. So 2 and 2 2s are 4, 2 zeros are 0, 2 10s are 40, 2 10s are 20, 2 5s are 10, and 5 1s are 5. So again, we are going to check if there's the commons of 2. So 2, yeah, we are getting 2. Okay, basically what we are going to do is, if it's a square root, so we are going to take, we have to at least find a pair of 2. Okay, and if there's a cube root, then we have to find some number which is going to come 3 times in the LCM, and then we are going to group them and take them out as one number. I'm not going to be going so detailed in my explanation for now, but just trust me, this is going to be 2 under root, and the rest of number 5 multiplied by 2 is 10. So it's going to be 2 under root 10 divided by 2. Sorry, it's -2. So again, if you divide it, 2 1s are 2, 2 1s are 2, and 2 1s are 2. So it's going to be x is equals to -1, or x is equals to -1 plus minus under root 10, and that's it. So it's -1 plus under root 10, or it's -1 minus under root 10. So that's it. And this is part G. For part H, we have got in a modulus 2x squared minus 3 is equals to 2x. So again, we are going to expand this up. 2x squared minus 3 minus 2x is equals to 0, or 2x squared minus 3 plus 2x is equals to 0. Again, rearrange this up. 2x squared minus 2x minus 3 is equals to 0. It's really easy. It becomes easy if we rearrange this. 2x squared minus plus 2x minus 3 is equals to 0. Again, I'm going to use the calculator for now. 2x squared negative 2 negative 3, and that's going to give us 1.8228. It's approximately x equals to 1.823. The other value is going to be x equals to negative 0.823, or x is equals to, the other set of values are going to be 2, positive 2, and negative 3. So again, I'm going to emphasize on the fact that please do try to find the answer. Wait a second. I think I've done something wrong right here. 2x squared minus 2x minus 3. 2x squared, yes, I've done something wrong. Plus 2x minus 3. Yes, so the thing is, I'm really sorry for that. Oops. Again, sorry for that also. So I accidentally put down the values for the other one. So it's essentially the answer for this one was actually x equals to 0.823, and the other value is x is equals to, oh wait a second, 2x squared positive 2 minus 3. Yes. So for this one, it's 0.823, and for and the other value is negative 1.823. And I'm really sorry, I put a comma instead of a point here. Oops. Negative 1 point. It's making me mad right now. Let's take the eraser tool, negative 1.823. And the other values is x is equals to, for the other one we have got negative 2. So going to be 1.823, and the other value is negative 0.823. So this is it for part H. Let me see if I've done something wrong or not. And I hope I have not done anything wrong. Yes, I think so. Okay, for part I, I've erased some space here. And what we're going to do is open this up. X squared minus 4x plus 7 is equals to 4. We're going to expand this up. We're going to get x squared minus 4x plus 7 minus 4 is equals to 0, or I've switched the side directly. So x squared minus 4x plus 7 plus 4 is equals to 0. Again, simplify this equation. X squared minus 4x plus 7 minus 4 is 7. It's going to be plus 3 is equals to 0, or x squared minus 4x 7 plus 4 is going to be 11 plus 11 is equals to 0. Let's just input these values into our calculator. We are going to get 1, negative 4, and positive 3. That's going to give us x equals to either 3 or x equals to positive 1. So 3 and positive 1, or for the second set of values, we have got x squared minus 4x plus 11, which is going to give us our values in iotas. And I've told you, for now, iotas we are not going to take in consideration. So for now, our values for part I is x equals to 3 and or x is equals to 1. So this is it. This is the end of question 7. Okay, so now we are going to proceed on to question number 8, and it's the challenge question. However, I do not think it is as hard as challenge questions are taken. So for question number 8a, again we have two equations. So y equals to x plus 1 is 1, and y is equals to x squared minus 2x minus 3. And as these both value are equals to y, that means they are interchangeable. So x squared minus 2x minus 3 is equals to x plus 1, or was if we open this modulus function, we are going to get two possibilities, a negative possibility and a positive one. So or x plus 1, or you can say x squared minus 2x minus 3 is equals to negative multiplied by x plus 1. Again, simplify both of these equations. X squared minus 2x minus x minus 3 minus 1 is equals to 0, or x squared minus 2x negative x will become here positive x, negative 1 will become positive 1 here. So negative 3 plus 1 is equals to 0. Again, simplify this up. X squared minus 3x minus 4 is equals to 0, or x squared minus 2x plus x is equals to minus x minus 2 is equals to 0. Again, solve this quadratic equation. For this part, we are going to get x equals to 4 and x equals to negative 1. Or for the other part, we are going to get x is equals to 2 or x equals to negative 1. So we have one common value for x, negative 1. So we are going to assume it as 1. So for the y values, we have to input the x values. So y was x, the basic value of y is equals to x plus 1. So for the first value of x, we have 4, and 4 plus 1 is 5. So this is the y value. Then for the second part, we have the value negative 1. So negative 1 plus 1 is equals to 0. So that will give us negative 1, 0. Again, for the third value, we have 2, and 2 plus 1 is 3. So this is the y value. And again, negative 1 has already come, so no need to repeat it again. This was quite simple as I promised. For part B, we have 2y is equals to x plus 4, and y is equals to 1 upon 2x squared minus x minus 3 in a modulus. So taking directly from the question, we are going to say that 1 upon 2x squared minus x minus 3 is equals to I think we need to simplify this first. 2y is equals to x plus 4. So what is y going to be equals to? Y is equals to x plus 4 divided by 2. That's what it's going to be. So 1 upon 2 x squared minus x minus 3 is equals to x plus 4 upon 2, or it's going to be 1 upon 2 x squared minus x minus 3 is equals to negative x plus 4. Let me extend this, divided by 2. So again, simplify this up. 2, when it goes here, it is going to multiply with 1 upon 2. So 2 multiply by 1 upon 2 x squared, these are going to be cancelled, essentially giving us 1 minus 2 multiplied by x, 2x minus 3 multiplied by 2 is equals to negative 6 is equals to x plus 4, or again it's going to be negative x minus 4. However, the 2 is not going to be affected right now, so we are going to take this up here and multiply it with 1 upon 2. So 2 multiplied by 1 upon 2 x squared minus x minus 3, oh sorry, minus 6 is going to be equals to negative x minus 4. So again, going to simplify this. X squared minus 2x minus x again minus 6 minus 4 is equals to 0, or simplify this, x squared minus x plus x plus x minus 6 plus 4 is equals to 0. Oh, by the way, this is not minus x, it's negative 2x. Sorry, I'm really sorry for this. It's negative 2x. So it's going to be x squared minus 3x minus 6 minus 4 is going to be negative 10 is equals to 0, or x squared minus x is minus 6 plus 4 is equal to negative 2 is equal to 0. So again, I'm going to input these values into the calculator. I'm going to get x is equals to 5 or x equals to negative 2. And as for the second set of quadratic equations, where we are going to get x equals to 2 and negative 1. And these are the values for x. For the values of y, we have to x plus 4 divided by 2. And so we'll do step by step. 5 is the x value, and what is the y value? 5 plus 2. I'll just show you for the first value only. 5 plus 4 divided by 2 is equals to 9 divided by 2, which is equals to 4.5. That's how we are going to solve the rest of these. For the second value, we have negative 2. Negative 2 as the x value. Negative 2 plus 4 is equals to 2. 2 divided by 2 is going to be 1. So negative 2 and 1. And for the third value, we have the value positive 2. So positive 2 plus 4 is going to be 6. 6 divided by 2 is 3. So again, this is the y value. And for the fourth point, we have negative 1 as the x value. And negative 1 plus 4 is equals to 3. 3 divided by 2 is 1.5. And in fact, it's equals to 1.5. This is for part B. Again, I'm going to erase the board for more space to continue up till part C. And part C is relatively easier than both of these questions, believe me or not. So we have part C, y is equals to 2x and y is equals to 2x squared minus 4 in a modulus. So again, we can say 2x squared minus 4 is equals to 2x, or you can say 2x squared minus 4 is equal to negative 2x. And that's going to be 2x squared minus 2x minus 4 is equals to 0, or 2x squared minus 4 plus 2x is equals to, in fact, plus 2x minus 4 is equal to 0. Again, I'm going to input these values into my calculator. I'm going to get, or in fact, for you, I'm going to solve it. So 4 2s are 8. So take the factors of 8. 2 4s are 8, 2 2s are 4, and 2 1s are 2. From these factors, you have to take out 2. That's relatively simple. 2x squared minus 4x plus 2x minus 4 is equals to 0. And for the other part, again, we have to find the factors for 8. So that's going to be 2x squared plus 4x minus 2x minus 4 is equals to 0. And most people do not know this technique, that try to do the thing that whatever symbol you have here, if it's a positive sign, try to make the first number of your breakdown a positive value. Okay, and if it is a negative number, vice versa. So that's the thing. If you have a positive number we are breaking down, make the first value the positive number. You can make the second value a negative integer, but try to make the first value a positive integer, and then that would give you better breakdowns for your quadratic equation. So 2x as the common, x squared minus 2 plus, and again it's going to be 2 as the common. Oh, sorry, I took x squared in between. My bad. Let me erase this. This is not x squared, this is only x. So that's going to give us plus 2 and x minus 2 again. Or again, take 2x as the common, x plus 2 and negative 2 as the common, x plus 2. Otherwise, that value would not be sufficient when we open this bracket. Is equals to 0. Again, we are going to do this. 2x plus 2 is equals to 0, or x minus 2 is equals to 0. And for this, x plus 2 is equals to 0, or 2x minus 2 is equals to 0. And that's going to give us 2x is equals to 2, x is equals to 2 divided by 2, which is equals to 1 essentially. And for the second value, we have x is equals to positive 2. For third value, we have x is equals to negative 2, or x is equals to positive 2. Oh, sorry, this is going to be negative 1 by the way, because positive 2 will come here and become negative 2, and negative 2 divided by 2 is negative 1. And opposite here, positive 2 divided by 2 on the other side is equals to 1. So we have four values of x again. What we're going to do is uh, take the corresponding y value step by step. So for the first value, x value, we have negative 1. What's the y value? Y is equal to 2 multiplied by x. So 2 multiplied by negative 1 is going to be negative 2. Sorry, 2 multiplied by negative 1, yeah, it's going to be negative 2. For the second value, we have 2 as the x value, and 2 multiplied by 2 is going to be positive 4. For the third value, again, we have negative 2. So negative 2 multiplied by 2 is going to be negative 4. Fourth value, we have positive 1. Positive 1 multiplied by 2 is equals to 2. And this is our answer for part 8C. And that's it for today. I'll meet you in the next lecture with exercise 2.4. We have at last completed this exercise. And hope you have a good day. Thanks.